the International Astronomy Show here at Stoneleigh Park in Coventry. It's the 4th year that it's run, and as you can see, we've got a fair number of British astronomy firms that have come to display their wares, and a number of talks that run over 2 days. Today is Saturday, so it's the 2nd day of the show, and we're looking forward to it. Okay, Ed and I are here at the International Astronomy Show. Hi Ed.
Hi. Okay, let's looking forward to it. Yeah, looking forward to it. I've seen some of the speakers before down at Stoneleigh, and they're very, very good. Interesting to see the stands and hoping to get some bargains as always, but possibly looking at a new solar scope. So we'll see what happens. Anyway.
Fantastic. Well, I notice the crowds are starting to go in, so we better go and join them. Yeah.
Yeah, which I've got in the box down there. Yeah, in the bag. Anyway, whenever you want to come round, I'm sure you don't want to carry them about.
So we've met up with Pete here, Ed and I. And Ed, I understand you're thinking of buying yourself a solar scope, is that right?
So seriously considering it, yeah. I mean, the prices are very good here, so.
So this is the Lund 50?
Yeah, 796.
796.
This has got the blocking filters are 40mm blocking filter. That's a 60mm blocking filter.
Right. Okay.
That's what you got. It's a 60mm blocking filter in there, and that's a 40mm blocking filter.
That's a different scope. That's a 60. That's a 50.
Well, but these prices are on both on 50.
Right, just down here, Ed and I have noticed the first quark sodium 9 filter in the country is on this scope here. You see the nice gold colour. I don't know whether the picture's going to be any good, but it's certainly looks good on the scope, especially with that nice purple Ultra Astro camera on the end and that gorgeous red library Starwave. And of course, they've gone and stuck it on top of one of the new Skywatcher AZ EQ6s. Supposedly better designed and better engineered than the old EQ6.
Three look.
Oh, in fact, we've got all three. Fantastic.
Hydrogen alpha, calcium and sodium.
Brilliant. Oh, it's a nice picture. Better get one of those for the club website. Here we've got the new ZWO ASI 1600 camera, which Ed informs me is the thing, but what really struck me just underneath it is those tiny point grey little flea cameras. They're minuscule. Distinct advantage that on any scope we carry those.
To Peter.
And look who we've met up with here.
Peter, what's his name?
Yeah, Peter.
Years after
No,
left the club.
the name of the people who bought it.
Somebody now in the background. It's quite a nice display being set up behind us. Dark Skies Tenerife advertising trips to them. When we were in Tenerife, and have a chance to go and see them. Not a particularly big show. So I'm here with Gary Palmer. Good to see you, Gary. Thanks for a few moments of your time. And you were just telling me about the new filter that you've got from Daystar, which we've got here.
That's right.
Gold one.
The sodium D-line filter.
First of 3 in the country, I hear.
Yeah. This was actually the first one to land on Wednesday. We got images straight out of the box. Yeah, so we had images on Wednesday from it.
Excellent.
The idea is to find a narrower band that's going to give people really a lot nicer viewing in our conditions.
Yeah. So just to remind people, we're talking about this bit here.
This bit
the one that's
here.
gold, not the purple one. That's the camera.
The top part's the camera.
And to compare it with the existing filters, we've got the Chromosphere from Daystar Park,
right.
which is the red one, which is a Hydrogen Alpha, and we've got the Calcium line one, which they've already produced, the blue one.
Yep. So they all offer different views, which we're displaying on the screen. Yeah. And the idea is to filter out a lot of the stuff that we don't need to see in white light.
Right.
So by narrowing the band, then we're actually filtering out stuff either side, and that's going to clean up the view. So it's going to make it more pleasurable.
So we're talking about visual observing here,
Visual
or
and
just photography?
photographic. Yeah, it's designed for both. So the camera comes off the top, very similar to this one here, and you would put your eyepiece into there.
Right.
Yeah, and then they plug in. You can get little 5-volt battery packs that last 2 or 3 days. Yeah, you can plug one in, or you can plug it into the mains, and they heat up. Yeah, and they've got a heating element inside that brings them onto band, and it's a lot more precise. So a lot of people are used to pressure tuners and other things on other soldering equipment, but the heated element's a lot more precise.
Right. So for people who don't know, the Quark ones fit into a standard telescope.
That's right.
You don't need a special solar telescope. They have the blocking filter and the Etalon built
That's
into
right.
the actual device.
And the
Fits in
only other
eyepiece
thing
end.
that we have in front of it is a UV-IR cut filter. So when we look at the diagonal there, you've got UV-IR cut filter.
Can we just take that off so you can see it easily on the video? Again, somebody might not realise what an UV-IR cut filter is. So this actually basically bounces back a fair whack of the,
that's right.
the
It
sun's
bounces
light
back a
to
lot of the
reduce the amount
energy,
getting into it.
and between the two units, so you can use this on anything up to 127mm telescope.
Is there a size telescope below which you don't need anything at all?
You could probably use it on a 60mm, something around there, but I would still be using one of these because it's going to clean up. Certainly if you're imaging, it's going to clean up the images for the camera. Right. Most cameras don't have a UV-IR cut filter on, so you're already taking it out of the system.
Okay.
If it goes over 127mm, then you would need an ERF on the front, very similar to this scope here.
It's one of those things that
and you get them in red and yellow. So
that's an energy rejection.
Energy rejection filter.
Yeah.
But the idea behind the system is they are quite expensive. Right. Energy rejection filters. So by this system, it's cutting down on cost dramatically. And that's really what it's about.
Excellent. And you were mentioning the pictures behind.
So pictures. Let's just move this one back so you can see it.
So this is a calcium view, isn't it?
Yeah. So if we start at this end, this is the new sodium one.
Yep.
Yeah. The next one along standard hydrogen alpha. With prominence, then we have calcium down that end.
Right.
And the final one is hydrogen alpha. So it's a 0.28 bandwidth.
Right.
And that starts to show a lot more detail up in the chromosphere of the sun. So all the systems work slightly different.
So if you could just perhaps just talk me through what it is you get with these three main ones and the differences they show.
What you've got to think about the sun, imagine it's an onion.
Yep.
This is the easiest way. Imagine it's an onion, and by each wavelength you're going to start peeling a bit of the onion away.
Right.
Yeah. So if we actually start at the outside, that's the outside of the sun. That's the full atmosphere outside.
Yep.
And that would be usually something like quantum. This one.
Yeah, I did wonder what this offered the other
that moves up in range, so they're really more scientific grade equipment. You know what I mean? So one of those about £15,000, somewhere around that sort of.
So that gives you very, very narrow.
Very, very narrow band. Then when we are moving sort of through the chromosphere, we're moving down a little bit more. We start to see detail.
There's more of a quark view.
That's the quark view. So what you've got to bear in mind is when we're imaging in hydrogen alpha, you only really see the chromosphere. You only see the sun's atmosphere. What you're not seeing is the surface.
Right.
So when we start moving into the other light bands, we're moving down underneath the chromosphere.
Okay.
And we're starting to look at the surface. So the next band down is the sodium.
Right.
So sodium comes in, we can start to see a lot of granulation. And a lot more detail. And both in sodium and in calcium, you can every now and then see prominences.
Right.
It depends on where the prominence is located, what the gas structure of it is. And so on. And then we move all the way down to the cold end. Right down to the blue end, and we're on the calcium. This is calcium H-line. So in a lot of other products, some other Daystar products, you'll see K-line. But with the H-line, it's easier to view H-line. So lots of people can't see with their eye calcium K.
Well, that's what the PST did when they
That's
produced the
right.
calcium
It's
one,
very,
wasn't it?
very dark. You know what I mean? And if they've got anything like cataracts or things like that, they just can't see anything.
Yeah.
Yeah, it's just a blur. With the H line, it's a lot easier to view with.
Right.
Yeah, so it makes it a lot nicer, more pleasant through the eyepiece. It's quite bright. Yeah. So, but when we're actually looking at the detail, you'll see now that we're actually seeing right down. Yeah, on the surface of the sun, you're starting to see the detail around the actual sunspot itself. Yeah, and calcium shows up all of the active regions. So you're noticing all the white areas. Yeah, that's showing up all of the active regions that are hidden by the chromosphere.
Right.
Yeah, so even sunspots, if they're not that large, it's a bit like our clouds. If you're out in space and you're looking down, our clouds are covering a country, you can't see it. Yeah. It's very, very similar with the sun's chromosphere. Yeah, it will cover the sunspots, so you can't see all of the detail in them. So the different bands allow you to study different detail, or to view it, or to image it.
Fantastic. Thank you very much indeed.
That's all right. No problem.
I'm at the Altair Astro stand, and there's a few things that have taken my interest in particular. Firstly, we've got the Optron Sky Tracker Pro that's come out. It's been over the last few years, it's been a fair whack of these tracking devices for enabling you to put small telescopes and cameras, especially when you take off on holiday with you, to actually be able to take night sky photographs. This one seems a bit more of a heavy duty version. That's actually just under 400 quid. A rather nice red library. I also noticed a glassing. What we got? There's a new Starfi designed clearly to produce you with a wireless hotspot for your telescope, coming in at 95 quid. But what stands out is just how small it is. And then we've been talking a minute or two ago about the new Daystar sodium line filter that's being produced, that's come out. We're only the first 3 in the country. In fact, Altair have got 2 of those, one of which I believe has been sold, and they're also available here. So we've got the standard sodium I mentioned, which is here. So that's now coming in at 1,150 as a special show price. We've also got standard quark, and in there somewhere we'll have the calcium one. Oh, here's the calcium one. Just a comparison. It'd be great to own all 3, I've got to say. When you have the red one. On top of that, we've got something that describes an interference eliminator. But in fact, what this is a tilt adapter. Quite expensive, 150 quid. A neat bit of kit. It allows you just to, you can put your eyepiece on top of your quark, and you can just move it around, or it's the other way around, Jake. Move it around like that. So it allows you to tilt it on top of the filter to actually get that perfect alignment, so that you're picking up those that light as it comes out symmetrically straight out of the eyepiece. So out of the filter eyepiece. Sometimes called an eyepiece, isn't really an eyepiece, it's a filter that fits on the eyepiece end, and then stick another eyepiece on top of that, which is what goes on the other side of that adapter. On top of this, we have a new camera from Altair, a rather lovely purple one in the corner there.
So actually that situation you are using it for.
So specifications of this, so the USB 2 called the GP Cam 2 with a 1/3 inch chip in it. Is it in mono colour? Okay. This is the widescreen centres stand. Just discovered the widescreen centre has now moved out of London into Cambridgeshire. Interesting. So what we've got here is something that's quite... One of the things that's sort of showing up at this show are these various little portable imaging platforms that you can either put a camera or a small telescope on when you go on holiday. A few minutes ago we saw the one at the Altair Astro stand, and this time we've got the Skywatcher version, a rather neat little red device called the Star Adventurer. Actually surprisingly heavy when you pick it up. I'm just thinking of that in my hand luggage, taking quite a bit of space, and they've got it demonstrated on 2 different mounts. We've got this one on a simple silk carbon fibre tripod, which is probably what most people would use. We've got a rather neat one that looks like it's produced by the same company, but in this case we've got it with a counterweight and the tripod. It's actually really quite heavy brute of a mount, in fact, even though it looks quite small. I suppose the idea here is that you would be able to actually stick quite a decent small telescope on that and still get some stability. Although I cannot really imagine that being transported by plane, certainly, as I could go in the back of the car quite easily. This one, a more practical setup and a lot lighter. But in this case, we don't have the counterweight. What an interesting question would be whether it's possible to make up a counterweight wherever you are. And this company doesn't, as I can see it, offer that option. But I did see it with a post-market company the other day, so offering for EQ5 mounts a device we could fill up with water or sand and create your own counterweight on holiday. And that might be a useful idea with this one. It's a rather nice red livery. I don't know how much energy it uses and what sort of battery would be required for it, but that would be the next question I'd ask myself. Now, apart from that, over here we have some rather beautiful looking Lunt telescope. This is the actual 50mm. Rhys, if you could just go over here with your camera, and you can just point into there and see it. That's the pressure tuned 50mm Lunt. There's 7 of these on sale at the show. At least there was yesterday. Sorry, 8 I should say. There were 7 at Telescope House, and there were one here at the Widefield Centre. As far as I know, those are the only 8 that are left in the country at the moment. They're on sale. They're at around about £760 for a B400 version and £860 or thereabouts for a B600 version. The difference between the two is the size of the blocking filter, with the B400 having a 4mm blocking filter and the B600 having a 6mm blocking filter, as opposed to the somewhat substantially larger blocking filter at a Quark, which might be something that anyone considering buying these things wants to consider. This is, however, a dedicated solar telescope at around about 50mm. Sorry, that isn't a Lunt solar telescope, it's a William Optics 71mm refractor. Okay. I'm with Matthew Armitage from Astrophotography courses. Good to
hello there, how are you? Thank you.
Hope you're having a great show so far.
Busy, yeah.
Astrophotography course. Astrophotography is one of the things that's becoming more popular. Yesterday there were a couple of talks about it.
Yes.
David from down there gave a talk, and also Peter Lawrence came and gave one. I remember. They're quite interesting. And obviously a lot of the equipment that's being sold is about astrophotography.
Totally.
And I'm sure that lots of people who are thinking of getting into it, thinking, how can I learn more about how to take pictures?
Exactly. Yes.
And that's where you guys come in.
Exactly.
So can I ask you a little bit about what you guys offer?
Of course. Absolutely right. Yeah. Well, we do a range of courses. One from basic talks on generally on how to take images and the type of equipment you need, right through to specific courses on deep sky, solar, lunar, high resolution planetary imaging, and the type of equipment you need, full run throughs on the raw data through to finished processed images.
Right. And these courses, are they online or
No,
go somewhere face to face?
No, it's face to face. We have the courses in Banbury.
Banbury?
Yeah, and you're
in Oxfordshire?
In Oxfordshire, yeah, North Oxfordshire, Banbury.
Yeah.
And you literally sit in the room.
So quite convenient one. And we're from
good.
Burton.
Oh, right, okay.
So it's only like a quick hour down the road. It's
Fantastic. Yeah, we get quite a few people from all over, actually from Italy. They come to the course, so that's quite good. But basically you sit in the room right next to the instructor. Yeah. And the equipment's there, and you can feel it and touch it, and the processing's done right in front of you in real time, right in front of you. So it's all pretty good stuff.
All right.
We're going to be offering a few other courses as well. There's some more coming out about the type of equipment, and a lot of people get telescopes for Christmas and things like this, and they don't know how to set it up, and it's a bit baffling. So we're going to be offering courses in that as well. So
introduction.
Yeah, introduction.
So talk me through one of the astrophotography courses. Let's say I wanted to come and learn how to process images. Generally courses. How many days are we talking about?
It's a one-day course.
One day.
It starts about 10 o'clock and it goes through until about 4 o'clock, depending on how many questions you asked. And typically it starts off with the type, generally the type of equipment you need and what you can use, and types of equipment compared to other equipment, and how to use it, the cooling, and all the different aspects of the demand and so forth, and whether you need it or not. And then it's literally up to the raw dating of the, depending on the process you're using, it'll be stacking or whether it's DSLR, the flats and darks and so forth, and more work at telling how to take them all and put them all together and process them all, and then it's into PixInsight or Photoshop into the processing.
Right. And I guess it includes some demonstrations of how to do this?
Yes, it will all be done in real time. So it will be, unfortunately, we can't take the data because I'd love to do that, but we can't because we can't rely on our weather. So therefore, the images are actually the images, all the webcam information is actually taken beforehand, and then that's processed in real time in front of you.
So will I get the chance to practice that in the course?
No, we don't allow that, but you can bring a laptop and do it while we're going along. So yes,
Right.
So you can bring a laptop.
So you bring your own laptop,
Yes.
your own copy of PixInsight or
Yes.
whatever, and then you can get a copy of that same data, and while the person's doing it, you can actually
Yes, we can do that. Yeah, we can do that. Yeah.
And then at the end of the course, will I have any materials to take away with me?
No, not really. No, but it's basically take notes and. I mean, the thing about these courses, they're so in depth.
Yeah.
And the people who are actually giving instructions know so much about the information.
Yeah.
You are discussing. You would be going away with the book.
Yeah.
So it's no matter. We have to really rely on the information you want and engage it to the people who are there.
Fair enough.
So yeah.
How much are we talking about?
It's £30.
So £30. Gosh. I can imagine a number of people would be interested in that.
Yeah, excellent.
Thank you very much. That's
Brilliant. Thank you very much. Excellent. Thank you.
Ready, Rhys? I'm here with David Bryant from Space Rocks UK. Hi Dave, nice to speak to you again. See you again. Yeah, you too. I remember seeing you last year when we came here, and also to see you around at Astrofest. You seem to be so busy at Astrofest all the time. You get a chance to speak to you. So this is your display. Great thing about IAS, of course, is you get a chance to have a much bigger display than you would at Astrofest. Yeah, of course. So we get to see all the different choices of rocks.
It's more expensive though.
Is it really? I didn't realise it. I assume the way around.
It's a prestige event.
Oh, okay, fair enough, yeah. So, what I'd like to do is start off by just asking if you could just give us a little introduction to what space rock collecting is all about, and then perhaps tell us what the most exciting items are that you want to do today.
Okay, well, my entry into this was doing a degree in planetary astronomy, and of course we know more about the planets from meteorites than we do from actually digging holes in the Earth. But basically, three types of meteorite. There's the stony meteorites, which are the oldest material. Actually, looking around, we haven't got any out at the moment. The stony, the oldest material, lumps of chondrites, things like this. These condensed from the solar nebula about 4.5 billion years ago. They have small circular or spherical objects in called chondrules, and they're the first solid matter in the solar system.
So those little things are the chondrules, in the...
And you can see them poking out of the chondrules.
Oh, right, okay.
So they're the oldest material in the solar system, and the planets are actually made from these by a process of accretion.
Right.
When they got big enough, these little planetesimals, the heavy elements would sink through to the centre to form a core. It's a process called differentiation. And as you probably know, there was a period of cosmic snooper going on, which about 4.2 billion years ago, where a lot of collisions occurred, which liberated the cores of these planets. And we have these nickel-iron meteorites, used to be called siderites. These are the cores of planets that were broken up. But I should say there are also nickel-iron meteorites which condense directly within the solar nebula too. So we've got stony meteorites, iron meteorites.
Right.
The most exciting from my point of view are the pallasites like this, and these are from the core mantle boundary of a planet.
Right, so that's a bit of both really together.
Yeah, exactly that. So you've got nickel iron from the core, and right on the edge where it's contacting the boundary you have olivine crystals.
Right.
So they're the rarest and the most interesting.
Right.
As I said, we know more about the core mantle boundary from looking at those. So they're the three basic types. But you also have a group called achondrites. These are planetary meteorites on the surface of planetary bodies like asteroids.
Right.
And because they're from a differentiated planet, they have no nickel iron in, they're not magnetic or anything like a normal meteorite. And these particular ones are called eucrites, they're from the surface of Fall Vesta. You get ones from deep down inside, which are called diogenites. Right. That's material deep down within. And of course, I'm sure your members will be aware, every planetary body in the solar system shows signs of massive collisions from Coventry objects years ago. Those collisions will churn up the surface and you get mixtures of eucrites and argonites. You get a new material called howardite. So those are the three achondrite types. Some achondrites, like these little ones here, that's actually if you like, part of the lunar regolith. That's actually a lunar meteorite.
Okay.
So you have planetary meteorites called achondrites, stony dry ones, and stony ions. There we are. That's the different types.
Can I ask you a basic question? Probably a simple answer to it. You said that's from Vesta. You said that's from the moon. How do you know?
Well, we know how things. We know these are from the moon because, of course, people have been to the moon and brought back 800 kilos of rocks.
Sure, but they didn't bring back that.
No, but they exactly match. The different isotopes of oxygen occur in different amounts throughout the solar nebula. Okay?
Right. Okay.
And each planetary body has a different relative oxygen isotope concentration.
Right.
We know exactly what the moon's is because we've been there.
Yeah.
We know what Mars is because it's been sampled by things like Spirit and Opportunity.
Okay.
So that's how we know that lunar and Martian rock are definitely from the moon and Mars. They're probably blasted off the surface by meteoric impact. Mars is covered with craters. Mars has also got some enormous volcanoes, shield volcanoes like Mons Olympus.
Yep.
The escape velocity of Mars is so low, I think it's about 8 kilometers a second, that even a volcanic eruption on Mars could throw rocks into space.
Right. Okay.
So there are some what are called plutonic rocks from Mars which have reached the Earth as meteorites.
Okay.
With the other ones, we've got a much better idea. Spectroscopy is basically the answer.
Okay.
So you get the relative reflected spectroscope of spectrum of, say, Vesta.
Yeah.
Believe it or not, it's got exactly the same relative reflected spectrum as a piece of that rock.
Right. Okay.
So if you shine a light on that, take a spectrum, it exactly matches the curve of absorption and reflection that you get from Vesta.
Brilliant.
And they've done it for any number of asteroids. And I think it's about 30 different asteroids have been identified as being origins of some meteorites.
Well, thank you very much for your time. Really appreciate it. Thank you. I'm at the Pulsar Observatory stand. We have an observatory at our house, which is actually just a log cabin, and Ed recently also built one that was made from a log cabin. But look at this thing here. This is what most people think of when they want an observatory. The real McCoy and dome at the bottom of the garden. You have to stoop a little bit to get in. Here I am. Inside the dome. Can I come on in? So this is quite an impressive dome, standing up about 10-12 feet, and put your telescope in the middle. Then you'll have to have an automatic shutter opening device, although there is an option here for just this one's actually just a hand one. Let's see how it works. I assume you just looks like you just pull it back. Not quite so sure. Maybe that gets attached to the slit that comes down. Yeah. And out here we've got an example of one of the sort of piers you might decide to put in the middle of your observatory dome. £505, going cheap today. Another version's behind us there, behind the guys. Wouldn't work in our house due to the trees at the bottom of the garden. At the last RAG meeting, Edman brought along his homemade all-sky camera. If you don't fancy making it yourself, Oculus will provide you one. Here's their version, the Oculus all-sky camera. I believe that's running at about £700 at the moment. In a rather nice metal container with a dome on the top, a 2.5mm lens. Comes with a USB cable and a separate power supply input at the bottom. Personally, 30 to 40 quid. Join Edman's workshop is going to set up soon. You've got to make yourself one. Bit of fun. I'm here with Michael Hattie. Hi Mike. Hello. Starlight Express. Thank you. Looking at your range of cameras and equipment here. Could you perhaps tell us a little bit about what it is you brought along to the show?
Okay, so we've got a series of cameras, starting at sort of an entry-level camera. Most of these are cooled, right. So they're for deep sky imaging primarily.
So this one will be one of your entry-level cameras?
this one is, so these are all our main sellers actually.
Right, okay.
So we also have what we call the Ultra Star. This is actually an uncalled camera, but we use it for outreach programs, targeting for outreach. So it's a USB powered and driven camera.
Right.
It's uncalled, but very, very sensitive still. It has a quantum efficiency of about 77%. But the great thing about it is that it just drops into the eyepiece of your telescope, and basically becomes an electronic eyepiece.
I can see the advantage of that is that a lot of people worry about back focus, don't they, on telescopes? This one you can push it in almost as far as it's required to get it to focus.
Yes. We also have some software called Starlight Live that comes with the software with the camera, and that automatically stacks the images as they come down. So as you're taking 20-second, 30-second images, the image builds up on the computer screen, so you don't have to worry about stacking the images and that sort of thing. So it really is a great entry-level camera and software package.
Right. So it's sort of giving you that extra magnitude that comes with the magnitude increasing magnitude that you can see at the eyepiece that comes with the camera. That's right. Allowing you to have that almost at the eyepiece experience.
Absolutely.
At the same time.
That's right. Yes. Once whatever you learn from using something like this is transferable when you start using bigger cameras. They all will work with the Starlight Live software as well. So it's really good at the package.
Brilliant.
We also have a range of filter wheels. They're all driven and powered through the USB.
Right.
So several of them have got the built-in Francis guide as well. So you can actually image and guide through with that Valentine use separate guide set.
Okay.
We also have a spectrograph, which is a new introduction.
All right.
This is
Starlight Express spectrograph.
yes.
It's a lot smaller than the high-res the other company.
Yeah, that's right. Yes, it's very compact as well.
It is.
So basically, with this, we've got the input through here.
Yep.
We have a built-in guide camera.
Yes.
So which is the one that loads direct to cameras, and effectively we have an astigmatic concave grating, and that basically takes all the astigmatism out of the brain.
So, don't mind me asking, how much is your spectrograph?
They're just under £2,500.
£2,500. Thank you very much indeed.
Thank you.
Would you like a burger? Are you okay with one?
Hi Paul.
Hello there, Andy.
Nice to see you again.
Good to see you again,
It's
yeah,
been
yeah.
ages since you last came to Rossington Astronomy
It
Group,
has,
I
but
think.
I'm itching to come back.
Oh, fantastic.
And, so looking forward to coming back and speaking whenever you can fit me in. We're here at the International Astronomy Show, and hopefully the Rossington Group, well, you're here sort of thing, so don't spend too much money.
That's right. There's quite a few of us here.
Spend a lot of money, won't you? Yeah. But, yes, it's a good buzz today.
It is.
Sort of thing. Of course, I'm here helping with the colleagues from the Sky at Night magazine, so promoting the magazine. So I hope everybody's got subscriptions.
Well, I've got to check mine in a second.
Exactly.
Those I didn't get the last month, so I didn't run out.
Serious stuff. Can't have that. But I hope the Roslington Group has lots of dark skies, sort of thing, because we've got the winter months coming up, so lots of night sky viewing. So fingers crossed that we get some clear skies instead of a cloud. Would help, wouldn't it?
Yeah. I think the last talk you came to speak to us about was it Photos of the Night Sky number 3?
It was Images of the Universe, volume 3.
Volume 3.
So I've got volume 4, 5, 6, and I've now started working on volume 7. So you have been warned, Roslington. You have been warned.
We need to get you booked in.
Yeah.
Great to see you again.
Lovely to see you.
Thank you.
You take care. Happy observing.
Now this is the binocular mount everybody really needs, one of these things. Or gun turret to everybody else. But that could definitely carry 100mm binoculars without any problem at all. I believe 280 quid, did you say?
£285 the basic price.
£285 the basic price.
For a heavier duty one, say for example the APM binoculars, you need more counterweight, so that puts you up a bit, so I'll have to quote separately.
And who makes these?
I make them.
You make them personally? Okay. So
Everything I sell on, mate.
Just Brian from Astro Parts there.
How are you? Nice to meet you.
We've been here, in fact, probably RAG members this weekend have spent more money at Astro Parts than any other display in the show, I reckon.
Very good.
Because Ed walked in and spent 100 odd quid.
Excellent.
And I gotta say, I've just bought a smaller version, this one of these.
Yeah.
So it's a Nosmondy Vixen mounting saddle, £50, show price today. I don't think there's anywhere else you can buy one at that price.
Excellent.
So, and again, you know, high quality, well-made stuff at a price that actually is basically Astro buy and sell prices.
Thank you very much.
Brilliant. Thanks very much, Brian.
Thank you very much.
Yeah. So Brian, you were telling me that one of the things that you do is actually make bespoke parts
Yes,
for
I do.
the telescopes.
Yes.
So you tell me a little bit more about that?
Okay, sure. For example, here I have a demonstration set of rings which I've made, and here are photographs of
What one Brian made earlier.
Yes, and here are photographs of the ones I've actually made for customers.
Yes.
14-inch Celestron, that's a 6-inch. Made these for this. It's now in America, this brass card. All the brass parts on the rings for them. Made this with a nice carrying handle for the chaps. They're 204mm inside diameter. So anything larger than that, I usually get water jet profile cut out because my mill's not big enough to do anything that big.
Right.
You know, that's all got to be cut out with a single sheet of metal. You've got to get that sheet of metal on your mill bed. You know, so that's why I get those water jet profiles out. Okay. The other thing is guiding gear. These are very useful for people that are doing astronomy imaging, you know, because then they can turn their guide scope onto a star. For example, if they're on a big galaxy with no stars in the vicinity, it's very handy to be able to do that. Also, there's this thing which I actually invented myself. This is called the Atlas clamp, right? And it's quite expensive, I have to say. These are £250, but they're a very safe way of mounting your telescope.
Oh, right, okay.
And it fits on exactly the same place as it did before.
Right.
And he took it off. And it's very, very safe.
So it keeps your collimation.
Keeps your collimation.
Keeps it very safe, and it'll take
everything.
about half a ton.
That's right. Yeah, exactly. It's called the Atlas clamp.
Interestingly, compared to most clamps, I noticed that
there's a small version of it.
But it's only got the one screw, which is interesting.
Yeah.
Whereas most stuff you want to.
Oh yeah. There you go.
Yeah.
Yeah, that's
so because of the design, it doesn't require anything more than a
no, it
single
doesn't. No, just a pin to stop it from moving out. You know? Yeah.
Oh, very clever idea.
Yeah. I couldn't design it, but I managed to do it.
Yeah. And just for the sake of people, a way of preparing with things. Here we've got the simple standard Vixen dovetail. So how much would you be selling one of these for?
Normally 24, but on the show today 20.
20. So that gives you an idea. If you go online looking for a Vixen dovetail, I would say 20, even £24.
Yeah.
There's got to be at the lower limits of the price
and of
range.
Course, should some people want them longer for adjustment of their focus, for their balancing, I can make them to whatever length they would like.
Reservations, that's the great thing about it. Well, I did promise I would mention about your binocular mount that the price you quoted to 285, in case somebody gets a bit confused, doesn't include the tripod.
It doesn't include the tripod.
And although it looks like a very heavy duty binocular mount, what people must remember is the binoculars are two telescopes put together, and so consequently you've got twice the weight. So though on here we've got an 80mm pair, which seems perhaps a bit over mounted on this, actually if you were buying yourself a 100mm pair of binoculars, then you wouldn't be feeling the same way at all.
No.
You'd be feeling this.
But it would work equally as well.
Yeah, and that would probably take 110mm pair as well. So, okay, thank you very much again, Brian.
Thank you very much for your coverage. Thank you.